So next, we have the Plenary Talk from 5G TN to 6G TN, three-pronged approach. Unfortunately, Ari is not here to join us, but Rico Jonti will be presenting on his behalf. I'll read a little bit from Ari's bio. So Ari has scientific and engineering experience as a researcher, project manager, and research manager in various domains of the ICT development. Projects under his command resulted in waveforms and system design for military radio communication radar systems, embedded device networks, future wireless radio communication, including cellular systems, cognitive networks, and navigation applications. Currently, he is heading as a professor a research group targeting dependable wireless solutions for business verticals such as energy industry, health, and automotive industry, including solutions for or utilizing 5G. He is the principal investigator of 5G test network, 5GTN experimental research, and a KPI on the H2020 Slices SC, 5G drones, and other projects. Thank you, Rico, for presenting on his behalf.
Okay, so good afternoon, everyone, or in Europe, and good morning, everyone here. So I will give this talk on the behalf of Ari, who is a professor at the University of Oulu. My name is Rico Jäntti, and I'm a professor at the Aalto University, Finland. So we are located in the south, in the capital area, whereas Oulu is in the north, and that's the radio capital of Finland. So we have the Nokia large radio sites, including the base station factory in Oulu. So I will be talking about 5G test network, from 5G test network to 6G test network, three-pronged approach on behalf of Ari. And I've been collaborating with Ari on this test network developments. We have been building federated test networks in Finland, combining the site that we have in Aalto with the one there is in Oulu. But let me first start by introducing the 6G flagship of Oulu. So that is actually one of the first sort of 6G hubs or research centers in the world. And it is in Finland we have Academy of Finland, which is the sort of equivalent of National Science Foundation, which is funding this, and Flagship program is a program that aims at sort of maximizing societal impact of research. So the 6G is one of those flagship programs, and that is now situated at the University of Oulu. So just starting from look briefly at what is at the University of Oulu strategy. It is a general university with many different fields, but especially in the engineering area, this wireless communications and 6G is really in a strong role. This is, seems to have some sort of automatization of changing slides, so I need to catch up with the speed. Okay, so here are some numbers. So one which was already shown today is that the 6G flagship has been producing these white papers, which have been very widely reviewed and read in the world. So there's almost 1 million downloads for 6G white papers. So that is part of this co-creation. I don't know how to get rid of this automation, but okay, so that is one big part, and the other one is facilitating collaboration between companies and academia, and then of course doing science. So this has been also very productive research activity. But then what is the main goal of this flagship program is the societal impact and business impact. So in those areas, there has been a lot of activities going on in Oulu, and this is rather large activity. So there are like more than 400 people working in this area, 32 professors and other senior researchers. Okay, so that is where it started, and now just recently, in the beginning of this year, a second phase of this 6G flagship was launched. And the current strategic research agenda, well, it focuses on wireless connectivity, devices, circuit technologies, distributed intelligence, and wireless computing, and sustainable human-centric services and applications. And there are research activities in 6G technology enablers, then 6G test network development, and 6G vertical applications, and then trying to have this kind of opinion leadership of 6G. And on the impact side, sustainability has a high role, looking at certain strategic vertical service areas like health, industry, vehicular, and energy. So it was like if you think about 3G, that was when it came, it was sort of focusing on providing mobile data, but it was actually 4G that did that in a correct way. Now it's a little bit the same that when we are talking about some of these verticals, there's been a lot of hype, but then when we have been discussing in 5G, but maybe it will actually realize in 6G. And then one very important reason for this research activity to be in place is the global collaboration. Of course, as for Finland, there are some national interests. Now we are trying to join NATO, so for us, collaboration with US is extremely important. And that is actually one of the reasons that we are here, and Ari is coming to Washington tomorrow to discuss about 6G research collaborations with US partners. And then regarding this talk today, this research infrastructures is a big part of this impact. And these are some parts of which are directly related to this flagship program, but then there are other things happening. So, for instance, Nokia is building a 6G radio park in Oulu for building a kind of a large-scale test network there. Also, there are activities of providing training for industry and trying to influence standardization and so forth. Okay, so let me briefly describe the strategic research areas that are happening in this 6G flagship. The first one being the wireless connectivity, and that is being led by Professor Matti Latva-aho. And it has three themes. One is advanced networking technologies, especially focusing on core networks and edge cloud, fabric continuum, AI-enabled networking, trust and security. That is led by Professor Tariq Taleb. Then there is wireless broadband access, which is led by Matti himself, focusing on more the physical layer things, massive MIMO, millimeter wave, and terahertz. And it seems that in 5G we have actually been discussing a lot of this millimeter wave, but at least in Europe all the deployments have been on sub-6 gigahertz. And there are some technical challenges in the millimeter wave, so maybe 6G will do the millimeter wave finally right. Okay, terahertz. Then terahertz might be something that is more like 7G stuff, but there's anyway, it's very interesting from a research perspective. Then the third scheme is massive wireless automation. So looking at the massive machine type communications and sustainable IoT, and that is led by Professor Hurley Ailes. Okay, then the second strategic research area is devices, circuit technologies and implementation. And that is, of course, important when we start talking about experimentation and test beds. And this is led by Professor Arne Passinen. And his expertise is the radio platform design, so hardware architectures, signal processing things. So really thinking about what does it mean that, how do we implement these features on an actual chips? As the data rate go up, then we actually start to have the physical limitations of hardware starts to kick in. So we are actually starting to reach those. And on the radio hardware, there's also Timo Rahkonen, who is then looking at the digital signal processing components, antennas, radio frequency integrated circuits, and then team C, which is experiments and proof of concepts, which is led by Dr. Marko Leinonen, and that's basically building at these proof of concept systems and doing radio frequency testing and fabrication and these sort of things. Okay, the wrong direction. Then the third strategic research area of the Flagship is distributed intelligence. So their theme A is computing on the edge to cloud continuum. That is led by research director Susanna Pirttikangas, looking at distributed computing, dynamic node placement, AI for edge, and edge for AI. Team B is distributed AI, which is led by assistant professor Sumudu Samarkun, looking at distributed inference, privacy, preserving AI, self-organizing architectures. Then Team C is distributed sensing and modeling, that is led by Professor Janne Heikkilä, looking at coordination and sensing, at communications, multimodal, 3D modeling, and data locality. And this is actually an area where the 6G Flagship is has a close collaboration between the Finnish Center of Artificial Intelligence, which is a flagship located at Aalto University. Then the fourth area is human-centric wireless services, and that is led by Professor Ari Pouttu himself. The first team there is this 5G and 6G test networks, and that is led by Olli Liinamaa. Then Team B is then related to strategic vertical areas, and that is led by adjunct professor Jussi Haapola. And Team C is sustainability and business, and that is led by Dr. Maria Matimikko Blue. And I know those persons quite well because I have been opponent for both Jussi Haapola and Maria Matimikko when they did their doctoral thesis. Okay, so now to the actual topic. So from 5G test network to 6G test network, 3 prolonged approaches. So yeah, in Finland we had a program, research and development program called 5G-TN, so 5G Test Network Finland. Started in 2015, mainly worked with using LTE equipment, and that was a federated test network, so that is where we combined the sites in Oulu and in Espoo and in other universities. Then gradually moving to 5G, University of Oulu and Nokia was quite early in this 5G area as well, so they had this 5G millimeter wave demonstrator in the Winter Olympics in 2018. Then they have been working quite a lot with operator-grade micro-operator networks, so local networks, and that is something that is now started to happening. So we are in Finland in place licensing model where you can actually build kind of a local micro-operators. So we have actually, like for instance, in our campus, our own operator. So we are the operator ourselves, as an example. Okay, then this 5G test network was selected into the National Research Infrastructure Roadmap, and then later on also in the European roadmap. And now also we have sort of evolved 5G functions have been added there, and now we are on our way towards 6G, and I will come back to those paths later on in the presentation. So this just shows, okay, there's a lot of details in this slide on how we have been building these test networks. As I said, it started with 4G, commercial 4G equipment with Nokia's evolved packet core. And then on the machine type communication side, University of Oulu has actually had a very strong track record in building various sensor network systems, so they had background on that. So it started from that, and then it has started evolving as the 4G has evolved to 5G. So moving from those sensor networks to NB-IoT, LTE-M, and now recently towards the 5G ultra reliable low latency communications. At the core network side, virtualization, slicing has been happening. And then in the radio side, moving to 5G standalone mode, and so forth. And then what is sort of planned is to start doing at some point some sub-terahertz experiments on the radio side, and continue adding 5G functions as they become mature enough to be able to do some tests. And on the sensor side, there is a plan sort of to start looking at the sustainability aspects and looking at the printed sensors and so forth. And the important part of this is the looking at this different kind of verticals all the time, trying to also participate in or give input to standardization and regulation, and this is all, of course, enabled by research that is being done in this area. So why do we need these kind of experimental test networks? This is just one slide that sort of shows the different kind of KPIs of the different verticals. And they are very, very different, I mean, in terms of what kind of coverage, what kind of data rate, what kind of latencies. And maybe in the beginning of 5G, I felt that there's actually quite a lot of technology push, that okay, this 5G should do this and that, but then now the more actually the community interacts with the end users, we learn what are their actual requirements. And that will have an impact on how, what kind of features and how they should actually be implemented so that they are useful. And then, okay, this is more of that different requirements. So then there are, of course, questions that if we build this kind of local 5G networks, how do they coexist? Okay, if we could actually get these millimeter wave systems mature enough that they are reliable and so forth, then the good thing would be that the interference is kept quite local, so then it's easier to deploy this kind of local networks. One actually big problem that has come across when we actually do these experimentations is that the 5G networks are really painful to configure and take into use. That is maybe something that when we start looking at 6G, then some more intelligence would be needed on the network side to help that deployment. So now if you take current 5G base stations, it has pages and pages of parameters, and there are like few experts in the world who know what those are and how to tune them. Okay, so the final thing, the paths to this 6G experimentation. So we have the strategic research agendas that are feeding that. Well, the strongest path, of course, is the 3GPP path. So there are the releases planned, and eventually new features, we'll call it 6G. Then one activity or sort of path is this ORAN, which maybe is not so much technology, but it's perhaps more a business model thing. Actually, technology-wise, at least our own experiments with ORAN platforms that are available currently looks that they are not really mature enough, and many of them are like poor cloud-based solutions. So running the physical layer in a cloud is a bad idea. It's really energy consuming thing to do. But that will gradually help. Like Qualcomm has made these radio chips for implementing base stations. So once those start to appear in products, maybe the ORAN starts to be more mature and useful. But the current ORAN platforms are are quite far away from commercial grade, except maybe the ORAN deployments given by large vendors, but in which case it's just that they have opened certain interfaces to their existing systems. And then there is the disruptive path, so really looking at new technologies. Joint communications and sensing might require new waveforms, and then completely new type of services might be enabled. We might use the radios for really accurate positioning. Okay, the RIS were mentioned, and all these holographic MIMOs, and going to terahertz, this kind of stuff could have an impact on 6G or maybe 7G standardization. But with this, I'll end my presentation. So if you have any questions, I can try to answer, but maybe if they are complex questions, I will forward them to Ari later on to answer.
Thank you so much.